Right, the topic of this lesson is congruent triangles. So by the end of this lesson, we want to know what is meant by the term congruent. We want to have an idea of what measurements we need to know about two triangles to be able to say that they are congruent. And we want to use the fact that two triangles are congruent to solve for some missing information in the two triangles. So first off, congruent triangles are the same shape, meaning that the corresponding angles in the two triangles are the same size, and they are the same size, which basically means that the corresponding sides are the same length. So what does this mean in practice? Here we have two triangles, ABC and PQR. These two triangles are congruent because they're the same shape and they are the same size. If we were to take one of these triangles and make it bigger, they would still be the same shape, okay, but they would not be the same size. So they would not be congruent, they'd be what we call similar triangles. But if they are the same shape and the same size, they are congruent. Now, we can say that, in this case, triangle ABC is congruent to, and that symbol means congruent to, triangle PQR. Triangle PQR. Now, we write this very specifically. When we say that ABC is congruent to PQR, it tells us that angle A and angle B, angle A and angle P are equal to each other in the two triangles, which is certainly the case, A and P. It also tells us that angle B is equal to angle Q, which is certainly the case as well, here and here. And if two of the angles are the same, the third angles must be the same as well. But the order tells us that angle C and angle R are the same. Okay. Same is also true of the sides. If our first two sides here are AB, that means our first side here is PQ. So side AB is equal to PQ. And so on and so on. So if we find AB here, PQ here, yeah, they're definitely the same length. So the order of those letters matters. There are a few ways of showing that two triangles are congruent. One is called the side-side-side method, or just SSS. If there are three pairs of sides between our two triangles that are equal, then the two triangles are going to be congruent. So in these two triangles that we have here, we can see that first off, that's not a very good B, but side BC is equal to side YZ. We can see that AB is equal to side XY, and that side AC is equal to side XZ. So we can say that triangle ABC is congruent to triangle XYZ. The next method is what is called side angle side. So if we know that two pairs of sides are the same and the contained angle, so the angle that is in between those two sides are the same, then we know that the triangles are congruent. So in these two triangles here, we have that side CB is equal to side YZ. We have that side AC is equal to side XZ. And the angle between the two of them, so this angle in here and this angle in here, the contained angle, are also the same. And that's what that little arc means that we see right there. So angle C is equal to angle Z. So we can say that triangle ABC is congruent to, let's make sure we get this in the right order. I think it's going to be XZ, XZY. Z and, oh, no, not XZY, because let's do XYZ. Why does it have to be XYZ? Let's see. AB is going to be equal to, well, we know that CB is YZ. The most reliable way of doing this is to match up the angles. So we already have angles C and Z matched up. We know that because these are congruent, that this side and this side are going to be the same. So angle B here, which is between the 1 tick mark and the 3 tick mark side, has to be the same as angle Y. And then our third angle here, angle X, and angle A have to match up. So ABC, which is X dot and then arc, is equal to X, Y, Z. Okay, so we're good. The third method is what is called angle side angle or angle angle side. If we have two pairs of corresponding angles and one corresponding side are the same size, then we know that our two triangles are going to be congruent. And this word corresponding is going to be important as we go through this unit. Corresponding sides are sides that are between two angles that are the same. Okay? Corresponding angles are just angles that are equal between the two triangles. So corresponding sides are always between equal angles. Okay, so let's take a look here. In triangle ABC, we have, in triangle XYZ, we have that angle A here is equal to angle X, the two arcs and the two arcs. Angle B is equal to angle Y, single arc and the single arc. And then we have the side AB, which is between angle A and angle B, and side XY are equal to each other. So we've got angle, side, angle. These two triangles are congruent. So A, B, C is going to be congruent to X, Y, Z. The second situation here is when we have a side that is not between the two angles, then we have to just make sure that those sides are actually corresponding sides. So in these two triangles, we see that angle A and angle B are the same. Angle A and angle Y are the same. Okay, we see that angle B is equal to angle Z, which means that, I don't know, we'll use this dot to indicate that angle C and angle X are going to be the same as well. Now, the sides that are the same length are AC and XY. Are these corresponding? Yes, they are, because AC goes between our arc and our dot. XY goes between the arc and the dot, so those are two corresponding sides that are the same. AC is equal to XY. So we can say, therefore, triangle ABC, make sure we get the A in there, is congruent to which angle matches up with A? It's Y. Which angle matches up with B? It is Z. And which angle matches up with C? It is angle X. So triangle YZX. So what can we do if we know, if we're just given two triangles and we're asked to show if they're congruent? Well, in this top pair of triangles here, we are given the lengths of all three sides in both triangles. We could label this. We could say A, B, C, and then we could do X, Y, Z. X, Y, and then Z. We can see that angle, or side AB is equal to XY. We can see that side BC is equal to YZ, and our third side is the same as well. So AC is equal to XZ. So our triangles are going to be congruent by side, that side property. triangle ABC is congruent to triangle X, Y, Z. Right. In our next one here, we're only given, well, we know that two angles are equal to each other. We know that angle A is equal to angle D because they are both right angles here and here. Right. But other than that, and we're given that side here and here, so side AP is equal to PD. Okay. That by itself isn't enough to show that the triangles are congruent. But we also know that this angle here and this angle here are opposite angles. So they're going to be equal to each other. So we can say that angle APB is equal to angle CPD. So now we know two angles and the side between them are the same. So by angle, side, angle, we can say that triangle ABP is congruent to triangle. What matches up with A? It's going to be D, C, and then P. All right. Our third example here, let's see. We've got two triangles ABC and we've got DEF. They give us the lengths of one side between our two triangles, here and here. So we know that BC is equal to EF right away. And they give us the sizes of two angles in each triangle. But we can see that angle F is equal to angle C, clearly. That's here and here. So angle C is equal to angle F. What about the other two angles? Well, B is 50 and D is 60, so those ones don't match up. But once we know the sizes of two angles in our triangle, we can always calculate the third. So we could say in this triangle, angle A is going to be 180 minus 50 minus 70. Angle A is going to be 60 degrees. So that angle matches up with this angle right here. So we use like two blue arcs to indicate that that's 60 degrees. And then over here we can calculate our third angle as well. Angle E is going to be 180 minus 70 minus 60. Angle E is going to be 50 degrees. So we could use, I don't know, three red arcs here, 50 degrees. That one is going to be equal to that angle right there. So this side that we know is equal, BC, is it a corresponding side? Yes, it is. It's between angle B and angle C, which are equal to angles E and angles F. So we already have C is equal to F. We can add in that angle B is equal to angle E. So now we know two angles and the side that's in between them. So we can say by angle, side, angle, triangle ABC is congruent to triangle. What matches up to the A, D, DEF. EF. Matching A to D, B to E, and C to F. Are these triangles congruent? Well, let's see what we can say here. We can say that angle K is equal to angle U. We can say that angle M is equal to angle S. Once we know that two angles are the same, we know that the third one is going to have to be the same as well. So we can say that angle L is equal to angle T. And then we just have to figure out whether angle side KL corresponds to side TS. So over here KL is between the one arc and the dot, but on the other triangle, the side that's equal to it, ST, is between the two arcs and the dot. So KL is not the corresponding side to ST because they go between angles that are different. So these two things are not congruent. All right, what if we know that two triangles are congruent? What can we do with that information here? Well, in this question, we're given two triangles, EDA and ABC. We're asked to find the value of angle X right here and side ED, which is over here. First off, are these two triangles congruent? Well, let's take a look at what we know here. We know that we know that this angle and this angle are going to be the same. So we can say that angle EAD is equal to angle CAB. And this is going to be 37 degrees in here. What else do we know? We've got sides that match up. We know that side EA and side AC are the same, and we know that side DA and side AB are the same. So we've got two sides that are the same and the angle that's in between them. So we can say that by side angle side, triangle ADE is congruent to triangle. Where did I go? I started with A, so I got to start with A there. I went to D, which means I have to go to B and then C over here. So once I know these triangles are congruent, I know that all of the sides have to be the same length, corresponding sides have to be the same length, and corresponding angles have to be the same. So the only sides I have left are CB and ED, so I can say right away that side ED has to be equal to CB, which has to be 2.7. So that was one of the things that they wanted us to find. What about angle X? Well, let's see. Angle X is between our side with 2 ticks and our side with 3 ticks. So it's going to correspond, let's see, 2 ticks and 3 ticks. It is going to be corresponding to this angle right over here. So X is equal to, well, this is angle D, which is going to be equal to angle B, which is 68 degrees.